My name is Corey Beasley, and I'm in Challenge 2016, and I'm going to be explaining the Math 2000 problem today. So we have a series of problems for math. The first one is we have to define the chain rule, or at least show how we would use the chain rule, and explain the concept. So I'm going to go ahead and do that right now. So the chain rule is basically stating that if you have to find the derivative of a function, and the function has another function within the original function, you have to go through a certain process in order to find the derivative. So that process is, say if I'm taking the derivative of f of g of x. Normally, I would just take f of x and find the derivative of what's inside, and then that would be my answer. But I have to do it a little bit differently when I'm doing the chain rule. So, and let me go ahead and write this up here. I'm gonna write chain rule. So, the steps I'm going to take is, first, if I'm given this problem, or a problem within a problem, first I'm going to take the derivative of the outside function. And the way I notate that is I'm going to write f prime of x with g of x on the inside. Now once you take the derivative of the outside function, you're going to leave the inside exactly as it is. So I'm going to do f prime of g of x. And the trick with the chain rule is once you take the derivative of the outside function, you then have to multiply your entire answer by the derivative of the inside function. So that would be f of g of x, or the derivative of f of g of x times the derivative of g of x. And that's how you would work the chain rule out. So we're told to show how we would do the chain rule 2 times or multiple times. So we're given the problem, we're trying to find the derivative of f of g of h of x. And we have to derive that. So we're going to basically do the same steps that we did down here, except we now have another function inside of the inside of g. So we're going to repeat the step one more time. So if we were to write this out, we would write it out as f prime of g of h of x. And then we, just like we did right here, we're going to multiply that by the derivative of the inside. And the inside right now is g of h of x. So we're going to go ahead and multiply that. Now we're going to multiply it one more time by the inside of the derivative, or the very inside. So we already took the derivative of the outside, we took the derivative of the second layer, and now we're going to take the derivative of the very last layer, the inside. So it's going to be time h prime of x. And that's basically equal to the derivative of this right here. So now that we've got that solved, we're going to save, or we're going to remember this concept because I'm going to have to apply it to my final problem. However, I'm going to prove the inverse tan derivative. So we were given the problem. Let's take the problem right here. We have the derivative of arctangent of x. And to me, the easier notation is just to put a -1 for the inverse of tangent. So I'm going to do it like that, if that's okay. Now, over here, we already know that the derivative of that is equal to 1 divided by 1 plus x squared. That's one of the given math rules, and that's already a known property of the inverse of tangent. Let me go ahead and write the derivative sign right here. However, what I'm going to do right now is I'm going to show you a different way of how to derive that, or basically the carried out steps of how to do it. So you're gonna have to apply the chain rule just like we just learned. So if you take the derivative of the inverse tan of x, or let me actually do this as well. Whenever you're taking the derivative of any inverse function, you're going to use this formula. So the derivative of an inverse function, I'm going to notate it like that, is going to be equal to 1 divided by the derivative of the inverse function. So that's basically how you're going to take the derivative of that. So if I can share it real quick.